Welcome to a new test and teardown video. This time it's a Topward pulse generator 8201. And it's actually really beautiful and pretty. I just packed this out of its original cardboard case, and to prove it, I'll show you. Here's the case with everything. Even the test cable here is still sealed. Isn't that amazing? So it's brand new in a box. I have no idea how old this one is. I can't Google anything at all. So this Topward company, I don't know, and this model, no hits on the internet. So this is, as far as I know, the only one. Nobody talked about it. But what can this do? I think it will do some pulse spacing. So this is the frequency, right? But here it is in time, and it's ×1 and ×10 with this one, right? So this is the pulse spacing, and then we have the pulse width, and it's the same, ×1 ×10, and I guess it's all analog, right? We've got a little bit of funny things here. Gate trig input, sync out, TTL out, variable out, and this variable output can be between 1 and 10 volts. We can of course run, that will be 3 running, I guess, or trig from a trig gate. I don't know what is the difference with trig and gate. It says gate trig in. That is weird, isn't it? One shot. Okay, so we are now in one shot mode, and then you have to push yes, one shot. Okay, you can invert and square wave. Okay, so that is what there is to. Oh, this potentiometer here is just stuck. You need to give it a whole kilo of force. And we got, what have we got here? Topward Electric Instruments Company Ltd. And it is Taiwan. So here we got all the information, and if anybody can Google that, and the voltages and stuff like that, and that is nice to know. Let's try and power this thing up. First I'm gonna turn on mains entry, and I see no power usage. And we got red lamp, and we got output. Let me see here what we got. So this is 5 kilohertz, and I can probably, yes I can. Haha, this is nice and smooth. So ×1. This is of course clear because I got the same time, right? So if I put on more time, look at that. Of course, then it is, this is my pulse time and this is my repeat time. See? Repeat time is constant. So if we have it here, let's play with the repeat time. See, that is the other one. And it's not affecting my pulse time, see? Oh, that is nice. I'm gonna go and play a little bit more with this. What else can we do? One shot. Of course, this is my fault. We need to go. Yes, one shot works. I think I figured this out. The difference between trig and gate. See, here I got a signal gate trig input, and that is the signal here in the purple color, so you can see the gate trig signal. And now I am in gate. So a gate means every time this input is high, this machine is going to keep sending out all those pulses, but it's always going to end with a complete pulse depending on the length on settings. You can see here what's going to happen. See, you have the pulse or you don't have the pulse. So that is how it works. So if I change the repeat time here, and I can of course also change the width of my pulses. So that is a gate. And if we go to trig, of course I only get one single pulse every time there is a high like that. And then of course it does not respond to pulse spacing, because now pulse spacing is handled during the trig, right? And here I have my pulse width. So that is what it's doing. And square wave, yeah, that is just a square wave triggered by the input, and then it does not respond to anything at all. Then it just, yeah, divide the input, of course, like that. And if we remove the trig on square wave and going to run, of course it's a 3 running thing, as you can see here. And then I can of course change the output like that. Okay, square wave, that is a little bit funny. It's actually responding. Okay, really? Yeah, it is. I had the idea it would be not responding to that one in square wave. So that is all out, and now it is in pulse mode, and then I have all those pulses. I can of course make some really, really nice and small pulses. Let's see how small a pulse I can do. Now we're zoomed in here. We got 100 nanoseconds. And then we go, yes, 100 nanoseconds. That is the smallest pulse I can do. And if I crank this up, yeah. So this is how it works. So it is about times 10, yeah. Anyway, that is how it works. Let's have a look inside. What is inside this fantastic unit? It uses 3.9 watts. So now we are inside. The circuit board isn't really screwed into the case or anything. We've got those fantastic plastic spacers here, and they hold the circuit board down with the same 4 screws that assembles the top and bottom parts. But I really want you to see this detail here. What do you think about this? Is this someone who is thinking carefully in 3 dimensions? How is this possible to make such a screw up? Oh, that is funny, isn't it? So there's not room for this, so it's modified, but the thing is the switch is carefully soldered into the PCB, and this potentiometer is also, so it's actually quite nice and stable anyway. But the front part here, there's only 1 screw, as you can imagine. So you can see. It's actually not that. Okay, here you can see this is nice and stable. And this one is doing a little bit of just moving a little bit up and down here. What they could have done is they could have modified the screw just to go to here, right? That could have been possible, and then they could still fit this. Nah, not really. Yeah, I'm not super impressed, but it takes a little bit to impress me. Or what? So here's the capacitor that's removed. We got all the timing here and all the adjustments for all the different pulses. It's just done here with trimmers. And the circuit is extremely simple. All we got here, there'll be some gates, and that's it. No op amps, no funny special timing chips or anything fancy schmancy. No. That is what there is to it. Quite nice. I gave the potentiometer here a little bit of contact 61, so now it is nice and smooth. And that is all there is to it. The two regulators here, they don't really get that insanely warm, but they do get a little bit of nice warm. Yeah. Oh yeah, what I did find, this IC here is from '89, and that is the newest. So we got some 87s. So I think this one is from '89. There isn't a lot more to say, really. Ooh, really? The transformer isn't really good. So it's hanging in those tiny little, see? That is a little bit under my standard. I would have probably done it a little bit better than this. But anyway, thank you very much for watching. I hope you had a little bit of fun. Bye bye.